Well, hello everybody, and welcome to the June issue of the Virtual Planetarium with Pete Lawrence and myself, Paul Abel. And as ever, we will start with the inner solar system and work outwards. So starting with the planet Mercury, well, it's rather poorly placed in the morning sky at the start of June, shining magnitude minus 1.0 and sits about zero point 0.5 degrees southwest of much brighter Jupiter on the 4th of June, both rising about half an hour before the sun. But it's going to be hard to see because the sky will be very, very bright. So
it will, yes, that's right.
It's not great for Mercury, really, is it, this month?
No, not at all. Superior conjunction occurs on the 14th of June, and Mercury then reappears from behind the sun into the evening sky. On the 17th of June, it lies a degree north of magnitude minus 3.8 Venus. Mercury, impressively bright actually, at magnitude minus 1.8. But the problem is they set 30 minutes after the sun and will be really hard to see. By the 30th of June, Mercury shines at mag minus 0.5. And it does set 70 minutes after sunset, so it gives you a bit longer, but it's dimmer.
And it's harder to see still when it's that low down. So quite a challenging target. Venus, not massively better than Mercury. Venus reaches superior conjunction on the 4th of June, so that's when the planet is on the far side of the sun. So if you imagine a straight line with the Earth, the sun, and Venus at the other end, that's superior conjunction. And it's going to be very difficult to see at that time. But by the end of the June, it will be slowly moving away from the sun, and it will then be in the evening sky. So about magnitude minus 3.8, so quite bright, but setting just 30 minutes after the sun. This will continue to be the case for Venus for much of the next few months, but by the end of 2024, it will become a very good target. But
yes,
for now,
will.
It's a little bit hard.
And it will also become quite an impressive object as we go into the spring of 2025, which is always a good time for Venus to be in the evening sky, isn't it? Because it gets quite high up after the sun sets.
It does, and there's more people waiting to use Christmas telescopes to use it, and it's a good target to use to view on. So, yeah.
And also, that's the time when it goes into that beautiful crescent phase. That's the time when you'll be looking for the ashen light, of course.
Well, I wouldn't say looking for it, Pete. I keep an open mind and wait for it to appear. I have never seen it, but conversely, I've never seen the stealth bomber either, so that doesn't make it non-existent. But yes, that is a good time to look for it. More importantly, of course, people who are imaging Venus in infrared, if they can find the way to block the crescent, you can image the dark side, the night side of Venus. And lots of amateur astronomers do this now routinely when Venus gets into the imaging, into the crescent phase. And that's a very good way of trying to detect active volcanoes on the planet, which I'm sure are down there. They just haven't been properly caught in the act yet.
No, that's really quite exciting, isn't it? That there's a new thing to look out for with Venus in terms of active volcanism. So that'll be something which will be a hot topic, if you...
Oh, very good.
Sorry, that's very bad. Okay, well, let's now slip out to Mars, which is best at the end of June. None of the planets are particularly good this month, to be honest, around the solstice period, but they will start to get better as we move into next month. But Mars is in the morning sky. It's magnitude plus 1.0 at the start of June. And it does rise 100 minutes before the sun.
Yeah, it's actually starting to become a viable target. We're recording this now before June, but towards the end of June, I'll be making a start on Mars because it will be a reasonable target by the end of June. So some people have already started observing Mars already. So it's a good time to begin to make a start on it.
Don't wish to be negative, but this is going to be quite a tricky Mars apparition, isn't it? Because opposition, which occurs in January 2025, is not a good one.
No, so Mars because its orbit is more elliptical than a lot of the other planets. It has two types of opposition. Well, it has three, actually. Three types of opposition. Aphelic ones, when Mars comes to opposition well away from the sun. That's great for UK observers in the sense the planet is high in the sky, but of course it's much smaller.
Yeah.
The perihelic ones are when it comes to opposition close to the sun. It's very large, but from the UK's point of view, it's very, very far in the south, so quite hard to observe from that point of view. And then you get the oppositions in between when they're almost perihelic, almost aphelic.
Yeah.
And those are the good ones for, well, practically everyone. But as you say, this is going to be an aphelic one. But it is true Mars will be small, but it will be really high in the sky. So that compensates it a bit.
It's very awkward, isn't it? It's like there's a sort of cosmic balance going on. You either get it big and low down or high and small. I think it's about, if I remember correctly, it's about 14.4 arc seconds it'll be in January.
And not that big for very long either. That's the other thing. We move away from Mars really quite quickly. So it's 14 arc seconds for about a month and then starts to drop down. But we don't get Mars every year, so I really get excited about it coming back into the sky.
Oh, yeah, it's definitely worth going for. A bit more of a challenge. Anyway, coming back to where it is in June, there's a 14% lit waning crescent moon, 3.3 degrees to the northeast of the planet on the morning of the 3rd of June. And the pair will be visible low together in the east shortly after they rise, say around 03:30 BST. By the 30th of June, although compromised by the lack of true darkness seen from the UK, because we're only about 10 days or so away from the solstice, Mars begins to establish its presence in the morning sky as it rises ahead of bright Jupiter. On the 30th of June, Mars rises around 0200 BST, which is 3 hours before the sun. So even though telescopically it's going to be pretty small, it's still nice to see it coming back into the morning sky. And actually that meeting with Jupiter and Uranus as well, which are both in Taurus, is going to be quite spectacular as we head again into further into the summer, basically.
Yeah, so it's a nice thing to watch out for. Moving on, we have the planet Jupiter. Probably best time to see this is at the end of the month. It's a morning planet. It's gradually pulling away from the sun's glare, and on the 1st of the month, it rises 20 minutes before sunrise. But by the 30th of June, that's increased to 2 hours. It rises 2 hours before the sun. So that's becoming a viable target as well now. So although you spin it as they're out of the way, Pete, I'm thinking of them more as coming back into being good targets again. It just means staying up all night or getting up early to catch them.
Yeah, it's an interesting situation actually, because I mean, let's face it, at the beginning of 2024, the planets weren't great because they were all lost in the glare. So I'm thinking of them as all sort of sitting there, just waiting to come out from the sun's glare. They're actually coming out from the sun's glare, but of course the solstice is causing problems with the brightness of the sky. So as soon as we go past the solstice and the sky begins, or the night period rather, begins to expand, then that will catch up with the planets moving out from the sun. And suddenly, from having no planets, we'll have a fantastic planetary display moving out into the morning sky. So I'm getting quite excited about that, because the planets are going to be good at the end of 2024. And, you know, you can be philosophical about it as well, because let's face it, the beginning of 2024 was pretty rubbish in terms of the weather. In the UK, I can't remember it being quite as bad as this for so long.
December 2023, I didn't get a single clear night. I mean, I know it's always a bit cloudy and a bit rubbish in winter, but this month, the few months of 2023 were the worst I could ever remember.
So hopefully those clouds will have got themselves used up at the first half of the year when the planets are out of the way, and then as we go into the second half of the year, they'll stay out of the way and give us a fantastic view of our solar system. Okay, well, let's also head out to Saturn then. Well, short nights and poor morning position will hamper the current visibility of Saturn. But there is a waning gibbous moon near the planet in the early hours of the 27th and 28th of June. And while we're there, we might as well just clear them up very quickly, because they're not particularly visible this month. Uranus and Neptune, the ice giants, they're not particularly viable during June, so we can forget them.
No. But as you say, Pete, at the end of 2024, basically the whole solar system is back on show again.
Yeah.
But for now, it's not particularly good.
Rubbish.
All right,
rubbish is the term I'd use.
We have rubbish. Absolute rubbish. Okay, well, we got a couple of specials this month, and on the 7th of June, can you spot the 2% lit waxing crescent moon, which should be visible shortly after sunset, but it'll be very low down above the northwest horizon. I quite like these.
Yes,
really
I do too.
Thin lit crescent moon, because they're really quite pretty. And you know the interesting thing, although the same 1-2% of the moon is largely lit each time, because of libration, the crescent and the details on the terminator look ever so slightly different each time.
Yes, they do.
So they're really worth pursuing.
Well, that comes into its own, actually, on the 8th and the 9th, when there will be a chance to see the quite impressive crater, actually. It doesn't get a lot of press because it is in the libration zone, but it's Humboldt, which is a superb crater.
It is. Could you imagine if Humboldt was on the Earth-facing side? I mean, it really would dominate. It would be a very well-known crater.
Yes.
But as you say, because it's on the edge, it's quite foreshortened. But a good libration does allow to show you quite a bit of structure in it.
Yes, it does indeed. And on the 11th, I'm going to mention this now. We've got what do you mean, oh?
Well, because don't oversell it.
I won't oversell it. Potentially, the naked eye comet C 2023 A3 Tsuchinshan-ATLAS. That's potentially naked eye in the autumn, I should say, not at the moment. It should be currently brightening.
Yeah.
But if you've been following it, have you seen it yet?
I haven't. It sounds strange, but even with a large telescope, a faint comet, so a comet below magnitude 10, really, in a fairly brightish city sky, even with a 12-inch telescope, is a really difficult target. Because the light is so spread out over a region, I find it really difficult. I haven't tried. I need to try again for it, but we've had so few clear nights, I've had to prioritise what I want to observe. But
I agree, yes.
Unless comets for me visually are about 10th magnitude or brighter, I find it really tricky to see them visually.
Well, I would recommend you get your act together and get out and have a look at it, because I caught it the other night when we had a brief, clear spell. I photographed it, and I reckon it was heading up to about 9th magnitude, and it should be about magnitude 10, and you can see a definite tail on it. So it's very small and stubby, but it is definitely there.
Okay.
So that's quite positive. Now, we have to say this with a bit of caution. This is what you were alluding to at the beginning, that a comet, you never know what it's going to do. Things can happen in the comet which can disrupt it. One of the biggest that this happened to in recent times was S1 Ison, which everybody said was going to be the comet of the century.
Oh, yes.
Bigged it up. Everybody was crowing about it. Amazing, amazing. Actually, with Sky at Night, we went to La Palma, and I did get a fantastic photograph of it on the night, or a night before it got really close to the sun, and then it just evaporated.
Yeah.
And disappeared when it was supposed to do its thing. So you need to treat comets with a bit of caution. This one has potential to get up to easy naked eye, but because its orbit takes it between us and the sun, there is an effect as we go into September, more October actually for us in the UK, when the comet can be subject to an effect called forward scattering, and that can increase the brightness of the comet significantly. So if it has a lot of dust output and got a big tail, you may get a brighter object than the predictions would say. But we have to treat it with caution. Don't overhype it. Don't say it's definitely going to be bright and a comet of the century and whatever, and just enjoy what it delivers. We're in astronomy, we're supposed to be observing and recording things, not hyping them up to distraction.
Completely agree, and it does more damage to astronomy than not, actually, because people think, oh, it's just all overhyped, there's nothing to really see here. Personally, I'm not bothered whether it reaches naked eye visibility or not. I will enjoy determining its magnitude, plotting a light curve, and following the changes as it passes away from the Earth again. So I'm quite happy with that. I don't need it to be a big blazing comet lighting up the night skies. If it does that, brilliant. But they're beautiful objects to observe in their own right.
They
and I don't
are.
impose any conditions on them.
Here. Oh, we've ranted on about comets, haven't we? Okay, well, let's now move on to the 14th, when if you can find the moon in the day and you've got a telescope, a reasonable sized telescope, and you have a look at the crater Aristillus, around 5 o'clock in the afternoon, BST, there's a clair obscure effect. I quite like this one, where the light from the sun just clips the tops of the mountain peaks inside the crater, and they look like a little open cluster of stars, and that's called the stars of Aristillus.
And on the 16th, if you use binoculars or a telescope to see the moon on the late afternoon in daylight, you should be able to pick out the jeweled handle clair obscure effect. This is the illuminated arc of the Montes Jura extending into the lunar night. At 1900 BST, so 6 o'clock UT, under daylight conditions, the star Spica, this is the brightest star in Virgo, the Virgin, lies 25 arc minutes south-southwest of the 73% lit waxing gibbous moon. So see if you can find that.
That's quite good, actually, under daylight conditions, remember.
Yes.
So if you find the moon, then the moon's apparent diameter is about 30 arc minutes. So you need to bear in mind that if it's 25 arc minutes south-southwest of the moon, that's 25 arc minutes south-southwest of the centre of the moon's disk. So it's just 10 arc minutes south-southwest of the moon. So about a third of the apparent size of the moon to the south-southwest, you should be able to see Spica.
Yes.
In daylight.
Which is quite a thing. On the 17th, the UK experiences earliest sunrise of the year. After that, the nights start getting longer, although not immediately. It's not immediately obvious that that's happening. And then on the 20th, the sun reaches its most northerly point against the background stars at 21:51 BST. This is a point in time known as the Northern Hemisphere's summer solstice. Conversely, that will be the winter solstice for the Southern Hemisphere.
Yeah. On the 22nd, we've got another interesting lunar feature. This one I really like, actually. It's quite difficult to see. It's on the moon's western limb, so that's the left-hand side, slightly towards the north. So it's the upper left part. Not about, where would you put it? About 9:30-ish on a clock face?
Ish. Yeah.
And this is called Einstein, and it's a large crater with a really large crater at its centre, which is Einstein A. And this really is a liberation crater. We mentioned that Humboldt was in the liberation zone. It's not quite in the liberation zone. It moves backwards and forwards on the moon's disk, but it never actually disappears behind the edge of the moon, whereas Einstein does.
Yes.
So catching it is quite tricky.
And it's a nice crater to see, actually, even though it is quite foreshortened, even when libration puts it onto the Earth-facing side. But it is got a lot of structure to it, and
yes,
it is very impressive. Also on the 22nd, lunar circumstances favour the Mare Orientale. This is a massive ringed impact basin on the moon's southwest limb, and the Rook Mountains beyond are... It is quite a striking feature. Again, can you imagine if this was on the Earth-facing side? It would be quite a stunning feature.
Oh, it'd be amazing. I always think that when I see it from the very foreshortened view we get of it. If it was actually just around a little bit more, it would be stunning, absolutely stunning. But no, that's not going to happen. On the 30th, we have the dwarf planet Ceres, which reaches opposition on the 5th of July, and that shines at magnitude plus 7.3. And it's quite easy to find because it lies within the teapot asterism's handle, or just to the southeast of it, actually, when it reaches opposition. So if you can identify the teapot asterism in Sagittarius, then you should be able to find the region where Ceres is. And if you do a sketch of the region or you do a photograph, then do it over several days and compare them. And if you see something moving, that'll be Ceres. To see it with the naked eye, you need binoculars at least at magnitude plus 7.3. And it's also worth mentioning, we've gone through the whole month there with events, but of course June is the first full month of noctilucent cloud displays, or potential noctilucent cloud displays. We didn't get many last year.
No, it was a bit disappointing last year, but you can't really predict these things, can you? I mean, there's vague ideas about what may or may not generate them, but all we can do is say, keep an eye out. Maybe this year we'll have a splendid display. Who knows?
Well, I think it's really important to record if you don't see them.
Yes.
Because a negative, if as time goes on, people would just say, 2023 was rubbish. But if you don't record it, then it gets lost in time. And it's important to make that record, because then in the future, if we do have waxes and waning displays of noctilucent clouds, we can start to think, what was the reason why they started to wax and wane? And, there are theories connecting the visibility displays to the sun's activity, for example. So it's only by recording the negatives as well as the positives that we actually can have enough data to do that correlation.
Absolutely. Negative observation is as important as a positive one. Okay, well, let's turn our attention now to the night skies. So if you follow the arc of the handle from the saucepan of Ursa Major, the plough, you'll come to the brilliant orange star Arcturus, which is the brightest nighttime star in the northern celestial hemisphere, and the main star of this kite-shaped constellation of Boötes, the herdsman.
It's very striking, actually, Boötes. It stands out pretty well. I mean, Arcturus is pretty obvious, and it's beautifully orange in colour, and the kite, or the pointed end of the kite, is marked by Arcturus. And if you have difficulty identifying the kite, it's the same height as the length of the plough, or the saucepan, whatever you want to call that pattern.
Yeah.
So it's quite big. Another thing, actually, just to mention while we're in that region, to the east of Boötes, of course, you have the constellation of Coronae Borealis, the northern crown.
Yes.
In fact, one way to find that is to use the saucepan and go from the tip of the pan through the tip of the handle, and then extend that line by the same amount again. That will bring you more or less to where this little backward C shape of stars, which is known as Coronae Borealis. Well, there is an interesting star there, which is quite close to the star Epsilon Coronae Borealis, which is known as T Coronae Borealis, which is a variable star. It's also known as the Blaze Star. It's a recurrent nova, which is basically a red giant and a white dwarf. And over time, the red giant passes material to the white dwarf. And when enough material has accreted on the white dwarf, a thermonuclear detonation will occur, and that will cause the whole system to brighten to about magnitude +2. It's what it's predicted to do anyway. So if it gets to +2, that's the same brightness as the brightest star in Coronae Borealis, which is Gemma.
Yeah, it's actually quite an interesting event. I've been following this star for a few years now, and I made it the other night, magnitude +9.8, +9.9, something like that. It's really quite a phenomenal thought that a system could go from magnitude +9 all the way up to magnitude 2.
Absolutely.
That is quite stunning. The predictions for this, they are only predictions because it's a very dynamical system, as you've just described. It's quite hard to model physically. The predictions are that sometime between, February, March and August, this thermonuclear effect you're talking about will occur. So you don't need any telescopes or binoculars to check this out. Just check Corona Borealis and see if there's a bright star there one night that there wasn't the previous night. And that's the observation. So a lot of people are waiting to see just how accurate the predictions can see.
So now is a good time to get a base level observation, because at the brightness Paul mentioned, which concurs with an image I took of it as well the other night, it's at its minimum brightness. Of course, by our luck, it's probably gone off before this recording goes out, but that'd be great, wouldn't it? The prediction is sometime up to about September. But having said that, celestial objects don't play by the rules all the time, so it could be after that as well. The period.
Well, they play by the rules. It's just we don't know all of the fine detail of the rules.
But basically, it's got a approximate periodicity of about 80 years, and it was about 80 years ago it went off last time. So so we've just got to keep an eye on it and record it when it goes off. But it'll be amazing when it does go off to think what is actually happening there in that system.
It will, and it's once a human lifetime, really, this event. So all we need is for it to happen whilst the Corona Borealis is in the sky, and for a clear night. So, then we can get to see it.
Yeah, absolutely. Okay, well, yes, you mentioned Boötes the herdsman. You follow the arc from the saucepan to find Arcturus, keep going, and eventually you'll arrive at Spica in Virgo. And Virgo is a large constellation which is above and goes to the east and west of Spica. To the east of the stars that form this large sprawling constellation, there are two brightish stars, well, they're middle bright stars, aren't they, which are part of Libra, the scales or balance. And they, if you keep going to the east of that position, you'll eventually arrive at the red supergiant star, which is Antares, which is the brightest star in Scorpius, the Scorpion. And that's a beautiful star. It's a beautiful constellation, but we don't see it properly from the UK because it never gets high enough for us.
No, the horizon cuts off the bottom half. You don't have to go too far south to see it, actually.
No, you don't.
I've seen the whole constellation from Los Angeles, which isn't that far south, really. And it is quite an impressive constellation. It does look like a crawling scorpion. And, of course, near to Antares, that red supergiant, we've got the beautiful globular cluster M4, which magnitude 7.5, quite an easy target, but a distance of 7,000 light years. And it is one of my favourite globular clusters because it's quite low down and difficult to find, even though it's near to a very bright star.
Yes,
you have to make sure the constellation is at a reasonable height before you try looking for it.
I'm still getting my head around the fact that going south, you've gone all the way over to the west to Los Angeles to get down low enough to be able to see Scorpius.
I mean, I also saw it from the south of France, but Los Angeles sounds more glamorous.
Yes, I get your point. Okay, well, above Scorpius is a large region of the sky that is relatively devoid of anything bright, and that's the constellation of Ophiuchus, the serpent bearer. And that's an interesting area of sky. The stars that make up Ophiuchus actually... they are unofficially known as the inverted flower pot, although in some cultures it's known as the coffin as well, because it's sort of a coffin shaped. But it's a strange constellation because it is really large, and it's the only one in the sky which actually has another one passing across it, which is Serpens. So you've got to the east of Ophiuchus, you've got the Serpens cauda. That's the snake's tail. And to the west, you've got Serpens caput, which is the snake's head. But it is quite a confusing region of sky, really, isn't it?
It is. And, of course, the stars that mark it out aren't particularly bright. But it is quite a distinctive shape. So rather like the square of Pegasus or Hercules, once you've seen it in the sky, you do tend to remember where it is and what it looks like.
Yes, it does. It does sort of mark that region of the sky because it's devoid of anything else. Well, I guess we ought to wrap up as we are sort of in this region, and the sun is going to be awkward at this time of year because of the solstice. But we will have things like the Milky Way, and we will have the planets, etc., coming back into view as the nights get longer and you have a longer period to see them. At this time of year, if you go out and you look up at the night sky, what you see are the brighter stars rather than the fainter ones. But it won't be long before true darkness starts coming back and we can enjoy the night skies properly again. So I think with that, we'll wrap up. And all that remains to say is thank you very much, Paul.
Thanks, Pete.